Welcome to solverfy.
.90. So we need to find a chart of nuclides, and we want to write down all of the isotopes that are stable with 60 protons, radioactive with 60 neutrons, and all nuclides of any kind that exist with A equals 60. So this is a neodymium that has 60 protons. And so at least one source for this in this case, we might as well just write neodymium and then the mass numbers. So one source for this lists 142, 143, 144, an asterisk we'll get to momentarily, 145, 146, 148, and 150. This also gets an asterisk. And that's because these are technically radioactive, but their half-lives are greater than the age of the universe. And when the half-life of an isotope is greater than the age of the universe, it's for all practical purposes, it's stable. So here we want nuclides with 60 neutrons that are unstable, and we also want ones that actually are recognized to exist. Otherwise, you could just come up with any number of protons and it'd probably be unstable. But ones that actually have been found. So here we have rubidium 97, strontium 98, yttrium 99, zirconium 100, niobium 101, molybdenum 102, technetium 103, I think RH is rhenium 105, indium 109, tin 110, antimony 111, tellurium 112, E, iodine 113, xenon 114, cesium 115, and barium 116. So now we want all of the nuclides that have a mass number of 60. And in this case, writing down the element symbol plus the mass number is redundant, just like writing down the element symbol is redundant here. I mean, strictly speaking, like you should denote that this is the isotope of this element, blah blah blah. But we know, for the purposes of writing this down in a reasonable amount of space on the whiteboard here, and reasonably neatly. So we have zinc 60, copper 60, nickel 60, cobalt 60, iron 60, manganese 60, chromium 60, and vanadium 60.